Okay, let's get going. So as we come to this lesson, I thought it would be useful to put up all the content that you kind of need to be aware of for this topic. Now, obviously, it's hard to remember every single thing, but really, if you look at the topics, these are the theorems and the converses, and you have to have a working knowledge of these theorems. Now, you can see lots of these we've been using for a while, and so they'll look familiar, like things like angles in the same segment, angles in a semicircle, line from center perpendicular to chord, exterior angle of a cyclic quad, tan radius theorem, tan chord theorem. So if you want to take a screenshot, you can now. But I just want, are there any questions about any of these theorems before we get going with the exam questions? I just thought it's nice to see the whole set of theorems you need to kind of have as this is your toolkit. You know, I always go on about the toolkit. So this is your toolkit that you're going to use to help you solve problems, together with whatever other knowledge you have from earlier, like parallel lines and stuff. Okay, then let's start with an exam question from a past paper. And if we look at this, what I want to encourage you to do is you always start by introducing yourself to the question. So let's take a moment. D, E, F, G, H are points on the circumference of a circle. So here's D, E, F, G, H. Now, the reason I do this is my brain gets a chance to download the information. I'm also told that G1 is X plus 20. So G1 is X plus 20. Now, where is G1? Oh, here we go. G1 is over here. And we're also told that H is 2x plus 10. So H is 2x plus 10, which is down here. We're also told that DE is parallel to FG. So here is DE, and here's. Give me a thumbs up if you feel like you know how to introduce yourself to a question, like I've just done now. You slow yourself down deliberately. You take some time to get familiar with the features of the drawing. And now some of that initial anxiety will go away because you're like, okay, cool, I'm getting to know. And then you start to think, what theorems might be involved here? So before we start, let me know in the chat, what theorems do you think might be involved in this question before we even start? And there's not really a right answer. I just want to know what theorems are kind of popping up in your head. Put them in the chat. Or you can raise your hand and we can unmute you audibly. What do you think? So I can definitely see Morgan. Angle center equals twice angular circumference. So it's not a bad guess, Morgan, but the problem is you don't have the center of the circle here. So because you don't have the center of the circle, I don't think that will play a role at this stage. Then another one, Taran said angles in the same segment. Yes, I see that one. Alternate angles might play a role. Yes, I agree, that one. That was, and then angles in the same segment again. Yes. Okay, I think we're on the right track and we're ready to start with this question. So what you need to do for me is you need to determine the size of DEG in terms of X. So I want you to try and do that. Find me the size of DEG in terms of X. And when you feel like you've got it, I want you to put the answer in the chat. So find DEG in terms of X. So first find where it is, and then you can tell me what you think that is. Okay. I see some answers are starting to come through. Let them. Yes, Kamali. I think I agree with you that there seems to be a Z shape or parallel line shape. That means that this one over here should be the same as this one over here. So we would say that DEG is equal to x plus 20, but then I need to also say alternate angles DE parallel to FG. So this is going to be x plus 20. Okay, next question. I want you to calculate the size of DHG. Now, where is DHG? Oh, here it is. They want to know what the actual size is. At the moment, we've got 2x plus 10. What do you think I'm going to have to do? I want some ideas, or maybe somebody could put their hand up and just give me a hunch. How am I going to find the value of x here? So Mola Mashile has said h equals g. I don't think h equals g, but I think you're on the right track. I think, unless, am I missing something? H equals g. Well, I know that, let me write this in. I know that that is x plus 20, right? So you proved that in the previous question. I do think making some sort of equation to solve for x is a good idea, but I'm not sure that this one over here and this one over here are equal. Maybe what other information might be useful in this thing? What other theorems might come up? Ooh, 2x plus 10 equals 180. Okay, Amukalani, you're getting warmer. What do you think adds up to 180 normally? So what do you think adds up to 180 normally? Ooh, Sadiq and Orakanisa, I think you've spotted something. So what I think has been spotted is that that thing over there is a cyclic quad. And what you know with a cyclic quad, so we would say x plus 20 plus 2x plus 10 equals 180. And we'd say opposite angles cyclic quad. Now, I want you to take this, find me the value of x, and then tell me what is the size of DHG. So over to you guys and girls. I want to see it in the chat. Let's have a look at what have we got. So I think x is 50, but that isn't the answer to DHG. What is the size of DHG going to be? Well, it's 2 times something plus 10, but that's something. What is that something? I think it's what we just found. So what is my DHG going to be? It sounds a bit like a GHD. Apparently that's a popular hair thing. DHG, so it's 110, yes. All right. Oh, flip, what happened there? Something ran away. Oops, there we go, we'll bring it back. Okay, so that wasn't too bad. Give me a thumbs up if you could follow that. Give me a thumbs down if you felt a bit lost with that first question. And then we're going to move on to the second one, I think. Okay, nicely, Ashley. So let's start with question number 2 for today. Let me see if I can just get this to Zoom. Let me push this one down a bit. Like that. And then let me make this one a bit bigger. There you go. Oh, let's move this out the way. Okay, so while you're waiting for me to move things around, I want you to have a look at the question on the board and introduce yourself a little bit. Let's have a look. So what do we need to do to introduce ourselves? In the diagram, O is the center of the circle. Okay, the moment I have the center of the circle, certain theorems will come into play. We've got the points on the circumference, which probably means a cyclic quad is going to be involved, or could be. BOD is the diameter. Okay, that makes sense. AC and BD intersect at E. So AC and BD intersect at E. That's just a normal crossing line. And then they tell us A is 51. So A is 51, which is over here. And we know that B1 is 29, and that is down over here. Okay, so I want you to start by finding me the size of O1, and I also want you to find the size of A2. See if you can do those two questions to start with. What do you think the size of O1 is? What do you think the size of A2 is? What theorem should I be thinking about for O1? I guess O1 is made up from this and this, but also that and that. So what is O1 going to be? And what is the reason I'm going to use? Because it's 2 marks. So 1 mark for the answer, 1 mark for the reason. So I agree, Morgan. Angle at center equals twice angle at circumference. And we have Mali has said same thing, which I agree with. RT, I'm not sure we get a right angle there, or Monoshile. Linda Kukle, I think I agree. Piwe, I think I agree. So let's have a look. I think this angle at the center, subtended by the chord BC, must be 102. And so we say that O1 is 102, and that is going to be angle at center is twice angle at circumference. So that's O1. Now, what is A2 going to be? Where is A2? Where is A2? Oh, A2 is sitting over here. So we have to think about that. Linda Kukle, let's unmute you and we can have a conversation there. What do you think the size of that one is going to be?
Sir?
Yes.
BD is a diameter. Angle A is going to equal to 90 because angle in a semicircle equals to 90. Then you're going to say 90 minus 51, which equals to 39, equals to angle A2.
That is fantastic. Well spotted. You were so quick with that. You got there before I did. So A2 is 90 minus 51. And the reason is we're going to go angles in semicircle. And you just have to notice that this big one over here has to be 90. Therefore, A2 must be 90 minus 51, which is 39 degrees. Well done, Lindo Kuchle. Okay, so good news is we've got that this is 39. We need to now find D. What is the size of angle D going to be? What is the size of angle D going to be? So I think I see a triangle here, and I've already got all the other angles. So I go 180 minus 29 minus 39 minus 51, and that will be sum of angles in a triangle. And yeah, according to what I can see, many students are getting this. They are getting 61. So we're going to get 61. Cool. Okay. Now let's see if this last one is a bit tougher. Determine the size of ACO. In fact, let me make it a different color. Where is ACO? Okay, we want to find this one over here. ACO. See if you can find that for me. Okay, so this is it's for 3 marks. Now what that tells me is I do have to think a little bit. So you've got ACO. ACO is the same as C1. Now, what can we do to help us? There's a couple of different ways we could do this. We know that one was 90. Look, we know that's 102 over here. What other things can we do to help us? I'm only seeing a longish way at the moment. Maybe there's a shorter way. I don't think this angle's in the same segment. The butterfly has to go the whole way. Can we go? Look, what I do think is that what you could say is that this whole thing is 61, right? So if that whole thing is 61, I've got no problem. But what you need is not the whole thing. You just need the little bit. But maybe what you could do is you could say, look, if I know what this and this is and take it away, or I was thinking, what if we got that one and then we got that one? I mean, this is going to take a while to get there. Then we got that one. Then we could ultimately work out that one. But that might take a bit of time. But you could do it with triangles, like I was just, and straight lines. Or you could do it by saying, what is the size of each of these? Oh, you know what? If this is 102 and these are radii, you can work out, that's probably the quickest. So think about this. If these are both radii. So what is the size of C2 or B2 going to be? So C2 is going to be 180 minus 102 divided by 2. And what is that going to give me? Who wants to help me? What's 180 minus 102 divided by 2? So what I'm basically getting is I'm getting the size of these two ones here. Okay, now the reason I did there was sum of angles in triangle, and I also used the fact that I had radii because these are coming from the center. Now, earlier on, we've said that angle C, basically big C or C1 plus C2, I'll call it big C, was equal to 61 by angles in same segment. But now if you know the whole thing is 61, right? And you know that this one is 39, my final answer for ACO is going to be 61 minus 39. And what do you get for that? It's going to be, it seems it's going to be 22 degrees. Now, if I went the triangle route and I found this and this and then and so on, I should get the same answer, but I think this is probably the quicker way to do it. Now, that was a bit tougher So I'm turning up the heat, but I just want to get a quick bit of feedback. Oh, okay. Mummy, I don't understand the equation you used to find angle C2. Let me go through it again. So first of all, what I did was earlier in the question, I knew that this angle at the center was 102. Okay, so that was sitting at the beginning. Then I know that these are radii because they're coming from the center of the circle, which means these two angles must be the same. So what I said was 180 minus 102 divided by 2, and I get that's 39 and that's 39. Now I don't actually need the one here, so I'll just leave it out. Now we also know that by angles in the same segment, this one over here and this one over here are the same. So that's why I know that big angle C is 61. But now remember, if the big blue one is 61, and I take away 39, all left is this one over here, which is what I was after. Okay, so I hope that helps you in interpreting it. Let's do one more before the break, and then we're going to take a break. Why isn't B1 the same as C1? Because they're not the same size, Junior. So it's a good question, but B1 and C1, these are not equal in length. Okay, so they don't have to be equal in length, but lovely question, Junior. Nice question, yeah. So Junior's asking, why isn't C1 and B1 the same? But they're not the same length, they don't have to be. Okay, one last question before break time, before halftime. Let's do this question. Can you find me, let's just try and enlarge this. So can you find me PRS? Find me PRS, find me the size of that angle using reasons, and find me the size of NST, which is this one down here. See what you can do. Okay, so PRS, so I see that there is this chord and it subtends an angle at the center. Now this one over here is the angle at the circumference. So this should be 30 degrees and it'll be angle at center is twice angle at circumference. So this should be, sorry, not, yeah, so this one is the smaller one. Okay, so that is, what is the value of NST going to be? And what else is given to you in the drawing is the other question. What else do we have here? So not parallel lines, but there are equal sides. Why do you think they've given you this side and this side is equal? What help is that? Why are they telling you that? You could have radii, but that would be more of this. These are equal chords. And what do you have when you have equal chords? So there's two theorems, but equal chords will subtend equal angles in two places, at the center and also at the circumference. So if you have two equal chords like you have here, if they make an angle at the circumference, I'm going to make an angle at the circumference, there's my angle, and then this chord also makes an angle at the circumference. Those angles are going to have to be equal. But the thing is, I already know that this one is 30. So what is this one over here going to have to be? This is using a theorem that doesn't come up quite as much. What's the size of this angle here going to be? So it's also going to be 30 degrees. And the reason is going to be equal chords, equal angles. So when you have chords that are equal, they will give you identical angles at the circumference. And also they'll give you identical angles at the center. So to give you a sense of how that worked, if you went to the center, if I made this angle, that angle would have to be 60 because you know that chord made that angle at the center and it's the same chord. And then in this one, this would have to be 30 because you're making it circumference. Okay, so that is a theorem that doesn't get used all the time, but it does come up sometimes. And so it was important I showed it to you. Okay, give me a thumb up if you're feeling, or give me faces. So happy face if you're feeling good, middle face if you're feeling like middle, unhappy face if you're feeling a bit lost. I want to see the faces of the people in the class, the virtual faces. Give me a sense of how you're feeling. The faces are so emotive and so funny to see all these little faces. Okay, now don't worry, we're only halfway through, right? And we're making progress, so I don't want you to be discouraged. We're going to carry on going after the break. But before we do that, we need to do some exercise. So let us stand up and just let our bodies relax. We've been doing, your brain's been working hard. It works especially hard with circle geometry. So it's important we invest in ourselves. So let's just start by swinging our arms a bit. Swing those arms and shake it out nice and loose like a piece of licorice. And shake out your legs. Feel the circulation coming back. Feel maybe like move your toes around a bit. And then let's do some circles, some small circles. Feel your shoulders rotating into big circles. And then change direction into big circles, going backwards into small circles. There we go. And then shake it out again. Make sure your body is loose, nice and relaxed. And then it starts twisting. Nice and slowly. Don't want to pull a muscle. And then as you relax, you can feel that your body can turn further. This feels good. Okay, let's do a tricep stretch. Okay, just hold it. 3, 2, 1. Another tricep stretch on the other side. Okay, and then let's just take 3 deep breaths. So in. In. One more. Okay, and then we need to get our blood pumping in our body. So we are going to do jumping jacks, which go like this. And I'm just going to try and do 20. Okay, see if you can hang in there with me. 3, 2, 1, let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, halfway. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I feel like both my body and my circulatory systems are all firing. I hope you do too. And then while we're just letting our heart rates come back, see if you can make 24 with either of these two cards. See if you can make 24 with either of these two cards. So Monomashile, let's have a look. So 8 times 4 would give me 32, but you have to still use these other ones. So how can we get to 24? Not quite. Well, let's just do the red one for today, because we actually need to get back to the circles. But who has an idea of getting to 24? So then 32 minus 8 would give me 226. So Bonga and Kovana has said 8 times 4 minus 8 times 1. Oh, did that work? Sorry, I think I've gone a bit. Oh, it does work. Sorry, I'm making things up here. That does not equal, oh my goodness, how embarrassing. That is indeed 24. Well done. Yes. And the one, so you would just go 8 times 4, which is 32, minus 8 times 1. And that gives you 24. Well done, everyone. Okay, back to circles. Let's continue on our journey. So the next question is going to be this one. And what it has is a prove that BC is not perpendicular, is parallel to OD. And we have a center of the circle that is involved. We also have CDE is a tangent to the circle at D. So there's a tangent there. Oh, this is important. DB bisects ABC. Now, if they tell me that, what I often like to do to remind myself, where's DB? It bisects ABC. Sometimes I like to put a little dot here and there, or put a little X here and here, just to remind myself that they've told me that these two angles are in fact equal. I don't need to reprove that. Like, these ones are given. And sometimes it can even be helpful to say that that's an X and that's an X. Okay. It even says let B1 equal X. Okay, so they've actually even told us that. So let me do that. So we'll make this an X, and we'll make that one an X. What are some ways that we can prove two lines are parallel? What are we going to try and do if we need to prove two lines are parallel? What ideas do you have? Any ideas? How would you prove lines are parallel? From what I can remember, if two lines are parallel, certain relationships will hold. So one relationship I could find would be that this one should be equal to this one, or that one should be equal to that one, or this and this should add up to 180. So we have three choices: alternate angles, corresponding angles, or co-interior angles. In this case, if those are equal, then I've proved the lines are parallel. And if these ones add to 180, then I've proved that the lines are parallel. So even whenever you see prove things are parallel, you're going to have that choice. Now, what I think, well, I want you to have a go, but what I think is going to happen is we're going to try and make other angles equal to X. So why don't you have a go and see what other angles can you make equal to X? And then maybe how does that help me get to this question here? So how is B2 equal to B1? So in the beginning, they literally said DB bisects ABC. So if we look, what is ABC? So ABC is this angle over here. I'll color it in. So, right, that's ABC. But the word bisect, or DB bisects, means to cut in half. So that's why B2 and B1 are both equal. And they said, let B1 equal X. So I hope that helps, Buchle. So, oh, do we have a diameter? Yes, we do. Tens of a chord. So we probably have to have that then, Morgan. But I get what you're doing there. I don't think we're quite there. Okay, Kavana has said, and I think I agree with this, that we could say that this one over here is 2x. Okay, so that's kind of helpful. Now, what were we trying to prove? We were trying to prove that BC, so this line over here, is parallel to this line over here. Or you could say that people are saying D2 is X. I don't know if I would say D2 is X, because D2 is, oh wait, is it, no, I don't think you can do that one. D1 is X. Yes, you could say that D1 is X. So how would that work? Okay, I think we've got enough information to help us. There's actually two ways you could do this. I will show you now. The one way is to use the 2x. The other way is to use the x. So if we say that O1 is equal to 2x, which I agree it is, and Kavana has given us the hand there, we'd say angle at center equals twice angle at circumference. So we know that one. Then we know that B1 plus B2, or angle B, is equal to 2x, and that's because it was given to us, right? It said that these two are equal and it's given to us. Therefore, BC is parallel to OD, and the reason, what relationship is there between these two angles over here? What's that relationship called? In terms of what I was talking about earlier, what relationship is there? Zwandile, I'll explain in a moment. So Zwandile has asked, why is this 2x? So Zwandile, if you imagine this arc making an angle at the center, and you imagine this arc making an angle at the circumference, you know that the angle at the circumference is half the size of the angle at the center. So that's how I did that part. Yes, so it's corresponding. So we would say here, corresponding angles are equal. They both equal 2x. So that's one way of doing it. The other way you could have done it is using the radii that were mentioned. So let me scroll up and see who said this. But Kavana said radii, and who else said radii? Someone else also said it, I think. Mbali and Zanele. So if you look, that's the one way of doing it. The other way of doing it is to look just at the radii. So I'll take that 2x out for a moment. If you notice that that is a radii and that is a radii, then this is x. So we would say D1 is x radii, and then we're going to look at the relationship between here and here. Now, what shape? So I'm going to say that angle B2 is equal to D1 because they're both equal to x. Therefore, BC is parallel to OD. What is my reason going to be? Okay, it's going to be alternate angles equal. So that would be the other way that we would do it. So when we look at as the questions get a bit harder, we start to see we have to prove and show things. So let's just move on to the next one now. The next one says, show that angle C is 90. So we need to find a way to show this is 90. But remember, we have just proved something. What have we just proved? We've proved that this, hold on. We've proved that this line is parallel to this line. Now, once you've proved something, you can use it going forward. So don't be afraid to use the new information that you've just proved. You've proved a couple of things. That's 2x and so on. So how are we going to show that C is 90? I'll give you some time for that. See what you can come up with. What is given to us in the question that we haven't used yet? What's the big piece of information we haven't used yet? Monomashile has said the tangent could be important. Absolutely. Orakanisa agrees. So what do we know about the tangent and the radius? So I'm going to say D1 plus D2, or you could say the angle ODC. Maybe I should say that. The angle ODC is equal to 90 degrees, and that is going to be tan perpendicular to radius. So we know that this is 90. Now remember, we need to show that this is 90. How are we going to do that? How can we connect those two? They're not corresponding, but you're on the right track. These two are co-interior. So you know that ODC plus angle C equal 180. And we can say co-interior angles BC parallel to OD, but you know ODC is 90, right? You just showed that. So therefore, C must also be 90 if it's going to add up to 180. So the only way we get to 180 is if this is 90 and that's 90. And they are parallel lines. So a lot of students would have forgotten that they've just proved these are parallel. So they wouldn't remember to use them going forward. And I think that's a common mistake that we make. Okay. So take a screenshot if you need to of the working out on the screen. Obviously, the video recording will come out soon. And maybe we have time for one more question here today. Are there any questions from the class before I move on? Give a moment to just any questions to come through. Otherwise, yeah, let's keep rolling. Okay, so what do we have here? Let's introduce ourselves. It says QS and PR are diameters of the circle with center O. So PR is here and QS is there. It says that PQ, so I'm going to do this, PQ is parallel to this one over here. It says N is a point on the circle such that Q1 equals Q2. So they are saying that this one over here is exactly the same size as that one over there. So what I do is I make a little marking so that my brain doesn't get confused. It then says blah, 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 and S1 is 48. Where is S1? S1 is sitting down here. So S1 is this angle down here. Okay, we're not going to have time to completely finish this question, but let's have a go at it to start with. I want you to find me the value of Q1. I can zoom in a bit. Yeah. Oh, that's a bit much. Okay, well, I can zoom to that level for now. I'm going to have to zoom out a little bit. So what do we think the value of Q1 is, given the drawing that's over here? Ask yourself, what are the theorems that I need to think about? What could be involved, etc. Ooh, Awam, look at you. Awam has dropped a big hint. So Awam has said that exterior angle of a cyclic quad. Now, what I noticed is I didn't actually see this for a while, but if you look at that, that definitely seems to create, it was almost like the cyclic quad was hiding. And I agree, well, there is an exterior angle. Now, I still haven't got my answer for Q1, but it definitely is something that sort of snuck in there. So what is Q1 going to be? We can do the first bit of writing, I guess. We can say, look, angle PQN is 48, and that would be exterior angle cyclic quad. But now remember that you have just got this whole thing over here. So what is the size of Q1 going to be? So because this whole angle is 48, but these two are equal, this will have to be 24 degrees, and you can just say here, Q1 equals Q2, given. Because you literally were given that. So, you know, you can use that to say each of these must be 24. Okay, let's maybe try one more part of this, and then we'll share the link. What is the value of R? This will be our last question for tonight. So what is the value of R going to be? So first of all, find R, and what is the value of R going to be? And then Kia, if you could just get the link to the quiz ready. What's my reason going to be? So where is R? R is sitting down here. And what is the size of R going to be? So R, you're right. So it looks like there's a butterfly, and I don't want to make this too, yeah, it's going to get busy, but I think Q1 over here, that over there, and that over there are the same butterfly. And so we can say 24 degrees angles in the same segment. Yeah. Okay, I'm going to stop at that point.